Okay, today is test review day. So let's go through these 20 problems as you guys get ready for test 12. All right, so a little bit of a break from what we've been studying so far and a chance to remember what we've already learned. Problem 1 asks, what is the area of a rectangular rug? So here's my rug. With a side length of x minus 4 and a width of x plus 4. So x plus 4 and x minus 4. In order to find area, I do length times width, right? So I'm going to go ahead and multiply x minus 4 times x plus 4 to get my area. I can do this a couple of different ways. If you recognize from our patterns, I have a special binomial pattern here. Remember? Where if I've got a minus b times a plus b, okay, then my pattern for this, let me move this down just a little bit, is that I'm going to end up with a squared minus b squared. Okay, that's what I should end up with at the end. I can also do this using the FOIL method, which is basically just distribution. Let's start with this one. Okay, before we go to the special pattern, let's just make sure we remember how this works. So I multiply the first two terms, so x times x is x squared. Then I multiply the outer two terms, which is basically me taking this one, I distribute it here, and then I distribute it to the second term here. So x times positive 4 is 4x. Then I multiply the inner terms. So basically now I'm going to take this term and distribute it. Minus 4 times x is minus 4x. And minus 4 times positive 4 is minus 16. So you can see once I put my like terms together, so I've got plus 4x minus 4x, that I will end up with x squared minus 16. Because these canceled each other out. Just like my pattern. Okay, so whenever we have a minus b times a plus b, we end up with a product of a squared minus b squared. Number 2, graph f of x and f of x equals x minus 4 on the same coordinate grid. Compare the graph of f of x equals x minus 4 to the parent graph. So this is the parent graph. Guys, I'm going to use 2 different colors for this. If you want to pause and get colors, that's just fine. And if not, you can do it with a pencil. But this goes back to the investigation that we recently did, where we graphed the parent graph, f of x equals x. Don't forget that f of x is another way to just say y. Remember? Okay, y equals x. And we will, and when we write out our comparison, we'll make sure we make reference to the y-intercept. So, for f of x equals x, parent graph, I know that if that's the same as this, if y equals 0, x equals 0. So it's going to go through this point, through the origin. If y equals 1, x equals 1. If y equals 2, x equals 2, because y equals x. And so on and so forth, and it will hold true in the negative realm as well. So if my parent graph, f of x, looks like this. Be sure to use arrows. If you draw your own coordinate plane, label it, or I will not give you full credit. Okay, we need to be always labeling our graphs, and don't forget that you need arrows on the ends of the line in order for it to be a line and not a line segment. Let's take a look at the next one. F of x equals x minus 4. In this graph, the slope is the same. I could rewrite it this way. Y equals x minus 4 because f of x and y are interchangeable. The slope is still 1. Up 1 over 1, up 1 over 1. It's implied in both of the equations. The difference is that this one is going to go through the y-intercept. Here's my y-axis. Oops, sorry. At negative 4. So I'm going to take a different color, and I'm going to put a point. I know that it intersects the y-axis at negative 4 because that's what that number tells me. The slope is identical, so these are parallel lines. That means up 1 over 1, up 1 over 1, up 1 over 1, and I just keep going, and it will be the same in the negative. okay? And I'm going to have now a line that looks like this. Okay. Graph f of x, did it? Graph f of x equals x minus 4 on the same coordinate grid, did it? Okay, compare them to each other, and when it says compare, it means use words. In other words, write a sentence, okay? So I'm going to just make some observations here, and I need to make sure that in my observation I use the y-intercept. So I'm going to say in the parent graph, f of x equals x goes through the origin. See how I'm using that y-intercept in my comparison at 0, 0. The next one, right, f of x equals x minus 4, and we use these words in our transformation. Remember, slides, shifts, moves down, any of those words are fine. So I'm going to use the word slide. Slides down 4 units and goes through, don't forget, they wanted me to use that y-intercept. Here's the y-intercept right here, the place where it intersects the y-axis. So it goes through 0, 1, 2, 3, 4, negative 4. Simple as that. All right? Okay, number 3. Find the degree of the monomial 4x to the fourth, y squared, z cubed. To find the degree of a monomial, you add together the exponents. The coefficient does not have a degree, okay? Just the variables. So to find the degree of this monomial, I add 4 plus 2 plus 3, and my answer is 9. That's it. Okay, easy as that. Next one. Multiply negative 4xy times this trinomial. In order to do that, I know I am going to need to distribute this term here to each of the 3 terms in this expression. Just keep those, be careful with your signs, and do the multiplication. So I've got negative 4xy times 3x cubed. When I multiply variables with exponents, I add the exponents. So my first term is going to end up being negative 4x to the fourth y, because I have an x here, 3 x's here, and I've got a y. Okay. Next term, did I do that right? Oh, for goodness sake. I'm sure somebody is trying to correct me right now, saying, Mrs. Voorhees, you forgot to multiply the coefficients, and I sure did. Sorry about that, guys. Don't forget to multiply the negative 4 times the 3, and get negative 12, x to the fourth y. Okay, next term, negative 4xy times 5y. So this is negative, this is positive. So a negative times a positive is a negative, right? Negative 4 times 5 is 20. X, no x is in here, so I just keep the single x, and I've got a y times y, which is going to give me y squared. Okay, my implied exponent of 1 and 1, I add those together and I get 2. Next, okay, so I got that one, check. Did this one, check. Last one, negative 4xy times 2z. Negative 4 times 2 is negative 8. I have an x, a y, and a z, and I've only got one of each one. That's the answer, okay? There's the answer to the problem. Just don't forget those coefficients like I did. Next, number 5. Quite simple, don't let this trip you up. 7x over y cubed minus 8x over y cubed. We are subtracting fractions. They already have the same denominator, so the denominator stays the same. And I subtract the numerators. 7x minus 8x is negative 1x. If you want to put the 1 there, that's fine. You don't have to. Negative x over y cubed is the answer. If I wanted to show work for that, which you should, it should be 7x minus 8x equals negative 1x or negative x, okay? Our denominators when we're subtracting fractions stay the same. Okay, number 6. What is the cube root of 64? That means what number multiplied by itself 3 times equals 64. There are a few different ways you can do this. If you can see my calculator, I am perfectly fine with you doing this on a calculator. I think Abby reminded us that this is in the math. If we touch math here, we'll find right there where it says cube root. If you wanted take a different root, a 4th root, a 5th root, a 6th root, a higher order root, you'd use number 5. But the cube root is already here under number 4, so I'm just going to click 4. And it's asking me cube root, and I'm going to say of 64, and I hit enter, and it tells me the answer is 4. Now that is just fine for getting the answer. That is the answer. But I need to see that you understand. So on your tests, okay, I need to see something like this. Equals, okay, 4 times 4 times 4. Does that make sense, guys? Okay, oops, this is 16, not 8. Don't add, multiply, because then I'll end up with 16 times 4, which equals 64. And that demonstrates that I understand what this means. Okay, a number multiplied, a cube root means that you multiply a number by itself 3 times in order to get the number that's inside the radicand. Okay, for number 7, even though we didn't get directions here in our study guide, what we're trying to do here is just simplify. So if I'm going to simplify something that looks like this, I need to factor it. See if anything cancels out, crosses out. How simple can I make this expression? So I have 4a squared plus 5a. When I look at this and I think, is there anything I can factor out of here? What do they have in common? The only thing that I see that these two terms have in common is an a. Okay, I can't pull out anything from the coefficients, but I can pull out an a. And when I put it back in here, kind of undistribute, I end up with 4a, right? Because a times 4a is going to give me my 4a squared, plus simply 5. Because the a, I needed to end up with 5a, and a times 5 is going to be 5a. Now, can I factor the denominator? And the answer is yes. I've got 8a and 10. I can't take out any variables because there's no variable in here. There's no variable to take out. But what is the greatest common factor that these two share? The answer is 2. 2 times 4a is 8a. 2 times 5 is 10. Hey, look at that. These cancel out, and I end up with my simplified form here, which is a over 2. Or you could write this 1/2 a. Either way would be perfectly fine. Now it doesn't specify here in your study guide, but on your tests, they're going to ask you to simplify, and they're going to ask you if there are any excluded values. Any excluded values. Now, an excluded value is anything that makes the denominator, not the numerator. The numerator can be 0, that's fine. An excluded value is anything that would make the denominator 0, because wherever the denominator is 0, this expression is impossible. It will be undefined. So I'm going to take this whole thing right here, 8a plus 10, and I'm going to set it equal to 0, and then I'm going to solve for a. Subtract 10 from both sides. That gets this away from here, and I end up with 8a equals negative 10. I'm going to divide by 8. And I get, oops. It would be okay with me, guys, if you just said a can't equal 10/8, negative 10/8. If you want to simplify it further and you want to reduce that fraction, that would be fine too. Okay, and then it would reduce down to negative 5/4. It can't equal either one of those. Those are the same fraction, right? But this is the excluded value, because if I were to take this value and put it back into the denominator, it would make the denominator 0. So we have to exclude it as a possibility. A cannot equal that, because if it does, it will make the expression undefined. All right, good work. Let's keep going on to number 8. Okay, for number 8, here I have got some simplification to do. I'm not solving for a variable. So if you end up with x equals something, you did it wrong, okay? I'm just trying to distribute this term to these. A couple of different ways we can do this, guys, and you get to pick. I'm going to deal with the negative exponents before I do the distribution because I don't like them. I don't want to have to deal with adding these negative numbers, so I'm going to move them. So this term right here becomes 1 over yx cubed, right? Because this negative exponent doesn't mean that x is negative. It just flips its position. It means it's in the wrong place. Same thing with this one. The z to the negative fifth, these are fine. These are positive exponents, +1, +1. Z to the negative fifth means that whoop is going to flip right up here. So here's what it becomes, x, y, z to the fifth. I haven't done any distribution yet. I'm just getting rid of negative exponents because I don't really like them. Okay, -3 down here, so that's going to flip. I don't have any negative exponents up here, so everything that's up there stays up there. Z, y to the fourth, x cubed. Okay, now I can go ahead and do my distribution. So I'm going to multiply this here, and then I'm going to multiply it here. When I multiply fractions, I multiply straight across. Straight across the numerators and straight across the denominators. So this 1 times x, y, z to the fifth is just x, y, z to the fifth over, here's my denominator, y, x cubed. Plus, okay, so did that one. Now I need to do this one. Here's going to be the numerator because I'm multiplying 1 times this, and this will be the denominator, right? Okay, so z, y to the fourth